Okay, so repeat a set of instructions for an exact number of times while or until a condition is met is one of the most powerful programming. Yeah, so okay. I've just always considered just while loops for hardware, but yeah, obviously I can start to do some for loops and do while, etc. So the slow simulation or step over function in Flowcode Simulator is useful to debug complex programs. Cool. Get about our background. All right, so objectives: create and use a running light program using the multiply by 2 method. Running light program using the multiply by 2 method. Okay. Create and use running light program using the shift right method. Okay. Create and populate an array. Create a conditional loop. So I get the shift right. I guess we're gonna just basically shift, turn that one on, and then just keep shifting. Multiply by 2. I guess it's the same thing as well, isn't it? In binary, you're just going up by a factor of 2. So okay. So write a program to make an 8-bit binary counter using a loop icon to count up from 0 to 1 to 255. Then reset and repeat the count. Display the counter value on LEDs. So we've already done that. Oops, sorry guys, can't see it. So we've done all of that bit. So modify your program to make the counter count up from 0 to 255 and then count back down to 0. Nice. Oh, nice. Have some fun, people. Okay, so we currently, well, let's do it in simulation first. So we currently count upwards. Oops. So what do we want to do here now? We want to say when it's equal to 128, then counter is equal to counter divided by 2. Yeah? So it's equal to 128. Still write to that output to turn on the last LED, and then do counter is equal to counter divided by 2. But then we need to loop. Oh dear, I don't understand flow code yet. Okay, because we need to loop in here now, because it will just divide by 2 once, and it's just going to go back and forth between these two. So how do I say if the counter is equal to 128, then I could do this in really ugly ways, like without. I don't like to write code without writing pseudocode first. So normally, what I would do is I would pull up Notepad, for example, and then I would start. I would start saying. So what I want is I want to count. So set my counter equal to 1. Then I want to count. Display that on LEDs. Then I want to counter is equal to counter times 2, and then if counter is equal to 128, then counter is equal to counter divided by 2, and then I guess it's like whilst if counter is equal to 128 and it's less than or it's greater than 0. So if counter is equal to 128 or damn, no, not and or here. If counter is equal to 128, then go to a while loop. Then whilst counter is greater than 0, counter is equal to counter divided by 2. And then if counter is equal to 1, if counter is equal to 1, then counter, then start again, basically. Go-tos is a really ugly way of writing code. You really should not use go-tos. And in C, I'd be using breaks and all sorts here, but I don't know how any of this. I don't really understand flow code, and I can see that they've got state diagrams here, so I kind of could use a state machine. But I guess I'm going to be writing with go-tos. That's going to get messy. So, all right, anyways, let's just try this. So, what have I said here now? If the counter is equal to 128, then I need a whilst. So I've got while 1 here. So whilst counter is greater than 0, then that should stop being true whenever my counter, or greater than 1, I guess, when it gets down to being 1 again. So whilst counter is greater than 1, then divide the counter by 2, wait 250 milliseconds, and write that to the output. This is going to be a little bit janky, but and then when that stops being true, I don't even need to set the counter back to 1, I don't think. So let's delete that, because then the counter becomes 1. So once the counter is now 1, it breaks out of this loop, finishes that if statement, comes back up to the top, writes that one value to the count to the LEDs now, and then multiplies by 2. So I think, if I'm not mistaken, that should work. Oh, what? What happened there? It ran a bit there. Look in the middle there. Why does it run like that? Look here. What happens there? So, okay, that's my counting down. Okay. So I don't quite have the delays right, I guess. Let's think about this. So I get to here and it just rushes back down. So, all right, just to make sure that I am beginning to trust the simulation, which is probably is a really good thing. But inherently, I don't trust simulations because, yeah, the real hardware is this is the real world, you know. I don't trust software. So hopefully we count up and then down, and obviously if simulation is correct, which I guess it will be, I'm beginning to trust it. It's going to race down quicker. So up, and then does the down bit really fast. Unless I'm losing it, I don't know. I might be just going nuts. It seems to do it in half the time. So why is the question? So there's no delay between bit 7 and bit 6. That's what I can see. Oh, sorry, you guys can't really see. Yeah, there's no delay between bit 7 and bit 6. So yeah, from what I can see, there's no delay between bit 7. Oh, yeah. So ticks up, and then there it just jumps. I bet if I double this delay, the illusion will go away. Maybe it's just an illusion. I don't know. We count up, and we count down, and that looks normal. It still skips there, though. It still skips there. No, maybe it didn't. This could be an illusion. I don't know. That looks okay to me. Let's just download that to the hardware. I don't know why that value in the while loop needs to be 2 times. There might be a hardware reason for it. I don't know. I'm kind of going off the fact that it's actually might just be an illusion. Maybe I can time it. All right, so I want a stopwatch. All right, where are we now? So if I start it when it counts up and stop it. Go. Stop. 3 seconds, okay? Then we'll count when it goes down now. Three seconds again, yeah. So yeah, and that's with the delay on the way down at 500 milliseconds. So, anyways, we shall move on. So make the count up from 0 to 255, then back down to 0. Use 2 loops inside an infinite loop so that the process repeats indefinitely. Download the program. Yep. Remember, Kit from Knight Rider. Wait, what college kid has watched Knight Rider nowadays? When was this written? Was this written in 2005? If this is like 2024, when was Knight Rider released? I don't know. Knight Rider released. Oh, is there a 2024 one? Maybe that might. 1983. So I don't remember Kit from Knight Rider, even though I was born in 1992. And then all the Cylon robots from Battlestar Galactica. Again, none of those. So write a program to write a simple running light that runs from port B, bit 0, to port B, bit 7, and then back to port B, bit 0 repeatedly. I've done it already. So we've done the multiply by 2 method. Let's try the shift right method. So I like bit shifting, actually. It's quite cool. So if we want to shift left. I believe that's how we normally do it. So we want to shift left by 2 or by 1. Oh, interesting, by 1. And then we want to shift right by 1. All right, let's simulate that. Yep, same thing. Lovely jubbly, lovely jubbly. Yeah, so to me, in my head, I kind of never look at bits as like numbers. I never really read them in decimal and say that that's 255 or that's 128. Maybe I should, but maybe, I don't know, being in a PLC world, usually I get given a word, and like what you'll get with PLCs, if I component libraries, how do I do this? How do I add text? I just want a label. Alright, anyways, I will just use Paint. It's just Flowcode. I'm not with it with Flowcode yet. So if I go to Paint, so usually with a PLC, what you'll get is so this is an 8-bit word, obviously, an 8-bit, a byte. You'll get a 32-bit word, and then they'll say to you that in the manual, they'll say these 3 bits here refer to, I don't know, let's say it can't be voltage, too small. Let's say we'll do a simpler one. Hopefully you get my point. So these 2 bits, and these refer to the position of the circuit breaker. So you got circuit breaker position. So with a circuit breaker, that can either be out. So if it's a 0, the circuit breaker is not connected. Let's go to here. Circuit breaker is not connected. So you got 0, 0. That means both bits are off. If it's 0, 1, then the circuit breaker is like connected into the system, but it's not on, it's off. And if you've got 1, 0, meaning that LED is on, that one's off, then the circuit breaker is connected and it's on. And then you might have like 1, 1, and that might be something else. That might be it's tripped. Yeah. So let's say you got disconnected, meaning the thing's not plugged in. Why is it writing so big? So you got disconnected. Oh my gosh. Disconnected. Come on, Paint, work with me, man. And then you've got connected, open. Me and Paint are not friends right now. Bloody hell. Connected, open. Then you got connected, closed. So open being obviously the circuit breaker is off. It's not conducting electricity. Closed meaning that's on. And then you got tripped. And so in a 32-bit word, what's wrong with Paint? Work with me. Bloody hell. There. So in a 32-bit word, you can have multiple of these. And so what you would do is you'd say, you'd take the whole word over the network, over Profinet, and then you would shift the whole thing. So these 2 bits here, so this is bit 3 and 4. You'd shift it right 3 times. So you'd write code and you'd just say shift 3 times, like that. So the same way on Flowcode here, now I've just written this code to shift the bit right. So it shifts right. You'd shift this bit right 3 times, and then you would and the whole word. How do I do an and symbol? Anyways, yeah, you write and the whole word with 0, 0, 0, 0 or whatever. You're basically gonna now mask off, and so you've shifted this whole thing. So now these two bits are now here in this position here, and then you just can delete and off the whole thing, all the rest of the words, and then now you've just got 2 bits there that you can just read into a tag, and you can call that tag circuit breaker position. So this is where like this sort of stuff is useful to learn. So and that's also why I prefer shifting as opposed to multiplying by 2. That would get confusing in code. But when you see shifting, you know that you're dealing with bit manipulation. Kind of easier to understand. All right, that was a bit of a tangent.